go.
Yeah, it's good.
Okay. All right, let's jump into it, folks. Last course of the year. After this one, you'll be all educated, at least in this field. So, a couple things on this course. One, we're going to discontinue the time cards. So no more time cards. With that said, lectures are going to be 8:15 in the morning, no exceptions. Right? So just make sure you get here for those. And get those, and then when you finish your stuff for the day, then you're welcome to do whatever you wish to do. So we'll kind of run that a little different. We're going to come into structural drafting, which will really kind of be a combination of a couple fields, and it's a good place for us to kind of bring everything back to the end. Let's just go through the syllabus. Study structural drafting procedures. Course activities focus on the use of our 3 element building materials. By that, concrete, steel, and wood. We're going to look at all 3 of those in pretty, get into the specifics of them, how they're made, how they're used, all the different scenarios we put them in. How they're used to engineer in the use of fabricating structures. We're going to be approximately 2 weeks. I hope to be done Wednesday of Dead Week, which will be not this week, but the Wednesday of the following. We should be done with the project, test on that day, and then your semester would be over as long as you have got everything done. I will leave Thursday and Friday for finishing up anything. I do have to have grades in, just so you know, Friday at noon on this semester. It's a little different than the others where I had through the weekend, but this one, everything has to be done on Friday. What you'll be able to do at the end of this, or hopefully by the end of this course, you should be able to do complete drawings showing concrete, steel, and wood and their structural configurations. And you should be able to identify the basic available configurations of these materials. And by that, they are cast in plants or made in plants. Most of this material is in specific forms. We usually bring it to the job site and then we fabricate it either at the plant or at the job site to match the job it needs to do. So an example of this would be, what's a W beam or an M beam or an S beam of a wide flange variety. And typically the old layman's term is an I beam, which we really don't use anymore, but we have different types of beams for different situations and columns to move. Okay, so that's really what we're going to focus on. Concrete, steel, and wood and their available configurations and then how we use them. We've got the best resource we have in the room for this is your architectural book. So it's listed as required. Chapter 43, excuse me, I should say chapter 42. I had to edit this for the new version. I got the wrong number already. This should say chapter 43. Or 42, excuse me, and we're doing the 42 questions. They changed this. Okay? So if you would make that change. Now, you might remember a little bit of section 8 from your text. This is where we looked at the framing of a door and a window and how those are done, what a king stud is, what a cripple stud is, these types of things. Chapter 8, we went into a couple of those chapters to look at figures, but we need to get into it in much more detail. That's where all of your beam design and your column design is also located. So we will be in that, which is chapters 27 through 31. Okay? It'll be somewhat of a review, but you'll be able to get most of it. Okay? If you want to have your Bertolini text around as a different source, we will be using welding and nuts and bolts to put these things together. Really, I think you'll find when you do structural drafting, the drafting is fairly easy until you get to the joints or how we are going to join these two things together. And then we get fairly detailed. So we get a lot of details in this industry. You might want to keep this around. Remember, your architectural text also has a welding section, but this is much more in depth. Okay? And so you got your fasteners and your welding chapter related there. So we're going to start into structural theory. We'll be in this for the first 2 days. Then we're going to go to concrete, then we're going to go to steel, then we're going to go to wood. And we'll look at each one of these components and their different capabilities. Okay. As far as what you are going to do, I will have some worksheets, and they're really not really worksheets, they're more vocab of specific items that is not covered in a text, but we'll get some of those. Several small details. I should say many small details. There will certainly be several by 3 or more, and I think we'll probably be closer to around 7 or 8 details for this one item we're going to do. We're going to do just one project for the whole thing, so it will have a plan view with it, of which you have a replica that I handed out to you already, and then we are going to fabricate everything that is used in the production of that. And yes, we will test on that Wednesday of Dead Week. Any questions on this? Well, let's jump right to your project. So I want to spend a couple minutes going over it, and then I want to really kind of introduce some terms that you're going to be dealing with in this industry. So let's look at this first so you can understand what it is. So this is what our client has brought to us. We have an existing restaurant. They want to, it's a 2-story restaurant. They want to bring out and put an upper deck for dining. Now, so what we've got to do is we've got to do a raised deck here that's going to carry a substantial amount of weight. In that we've got tables, chairs, patrons or people that go to the restaurant, everything that's required with them. So therefore, we cannot really do a wood deck here. We're going to have to do a concrete deck. And we're going to raise it up in the air approximately 10 feet. Okay. We use concrete for most of this. We can put cars on it, things of that nature. In this one, we're going to have people. Okay. So that's in essence what we're going to do. When you look at this drawing, here's the edge of the existing restaurant right here. Okay. So that's the edge of it. It goes back. It's just broken off. We don't need any of this. We're not hired to touch anything in this building back here. Okay, what we are going to do is install this deck onto the front of it. Now it's a different size thing. In essence, we need a 10-foot deck all the way around it. That's what we need. Your sizes are given, so it's 10-foot typical. We're going to have one section where we've got a 25-foot span. They want to leave this open because they'll also have seating down below the deck. We've got the large span out here in front, which is going to be 35 feet. And then we've got a little short one down here to kind of finish it off with 75 feet overall. You should draw this plan view today. We are going to have to put some columns. They're shown here, and I've put numbers on them because we're going to take them by numbers when we start running this. You're going to, I think, like this drafting. It's fairly easy drafting, but there's a lot of work that goes on in the background of what this is. Now, you'll draw one line, we'll label it with a beam or a column, but there's quite a bit of work that goes on behind the scenes to tell what that piece of material is. Okay, so we'll be doing some work calculating, in essence, how these things will work, and then we'll put them on the drawing. Okay. There is a quick section down below that's taken right here. It is really not known at this point exactly everything that's going to be used, but it is guessed at. Okay. So as far as this section goes, we've got the existing building right here. We're going to probably go with a steel column out here. That's what that is. It's an 8-inch by 8-inch. That's the outside. We'll go into that more. By a 1/4-inch HSS, which stands for hollow structural steel. So this is a piece of tube. Since we're going across the front, whenever we get around 20 feet, we're kind of getting towards the limit of what wood can do unless we get way big. And so we're probably going to end up going steel for this one, maybe even this one. This is right kind of at the limits of what wood can do with our spaces. That's why you've got right here a wide flange beam shown on top of the column. That would be this span. And then you see right here we've got our metal decking. And then we're going to pour concrete over the top of that and make sure that we're safe to code. We've got railings and stuff of that nature. And we will have a little slab underneath. You could draw this but you don't know a lot about it. You don't really know exactly what these members are until we get going. But it would be a good idea to kind of just put it together so you can get an idea of what's going on. For now, figure that the height of this wall right here is 10 feet. Okay? So you might just want to write that and use that as a guide.
And it has a slope.
Yeah, we'll slope it at about an 1/8 inch per foot. This will be done in architectural units. We're going to use a D sheet. So in essence, what I'd like you to do is 2 things today. I put a ton of questions for review up there. You don't need to get them all done today, but if you get the first half of them done, then you'll be to where we need to be tomorrow. So I won't make these due until Wednesday. But you can do half today, half tomorrow. I would like you to draw these 2 drawings today. Okay, and start setting up your drawing. And we'll jump into this and start sizing material on, yeah, maybe as early as tomorrow, probably more like Wednesday. Okay?
So as far as the plan goes, the existing building, do we just put it on here like you've done this one?
Yep. Yeah, we need to know where the existing is and what's the new. Now typically when you're doing an existing structure, that's going to be a light line weight, like a .012. And then all new material will go onto an OBJ layer, or at least the edges of them. And that way it really pops on the drawing, the new stuff. Any other questions off the top of your head on those?
You said a D sheet, right, for the project?
D, yeah, D. Let's talk about jobs. What do structural drafters do? Now remember when we're talking about structures and structural drafting, in essence this is a civil engineering discipline. Now, civil engineers do this work. You are supporting them or communicating their concepts to the design. What you want to think of in structural is that it's really the bones of a building, kind of like our bodies. If we had no bones in them, we'd be a puddle on the ground, right? So it's holding us up. When we talk about structures, and it doesn't have to be a building, it could be a bridge, it could be whatever. It could be a hoist, it could be a crane. They all have structural items. Or how do we withstand the physical forces we are going to induct on that structure? And it can be natural, such as wind, snow, those types of things, earthquakes. It can also be man-made, where we're putting a large cooling unit on a roof, or maybe we've got some high weight, like a parking garage, okay, where we're putting some different weights on stuff. So you're doing the bones of a structure when you do it, and that's all you're doing. That's all you're doing. So when we talk about the different jobs you can have out there, just so you know, a little background, we used to teach electrical drafting here, and I got rid of it because we weren't really placing anybody in it. And I brought this in because there's a lot of jobs in structural, and we're doing it instead. But I think even in the Twin Falls area, this would be a good discipline for you to get involved with. There's quite a few structural drafters in our area. Almost every civil engineering firm has some type of structural guy in there, okay? Guy or gal. So they will be doing that. If you go to JUB, EHM, Redicell across the street, they all have structural engineers that work for them. They all have structural drafters that support that work. So you do have that. Now when we're talking a structural drafter, there's 2 components of it. The structural drafter is a person that puts together like that big set of plans in the back where we go ahead and size our members, we show them the location of the structure. Generally, they also draft up the joints, but those joints may change. What they don't do is they don't configure individual elements. That's left for what we call a structural detailer. So a structural drafter will do the plan view and as many details as they need to accurately display how that's going to work in a building. The next one on here is a detailer. This is the person that actually makes the member and gets it shipped to the site. So they'll redraw the beam. They'll show where all the holes go for bolts, nuts. They'll show where all the welds go if we're going to weld things to it, how we're going to manufacture it, and then ship it to the site. So most structural items are drawn twice, usually by somebody in an engineer or architectural office, and then again by somebody like at K&T Steel here in Twin, where they actually make the beam. I guess let me kind of quantify that. They don't make the beam, they alter it for the job, right? They don't have a casting plant where they're making wide flange beams or channel or any of these shapes. So we have a few of these. Almost every engineering office, we've gotten quite a few of these. Now, K&T Steel is not our only structural fabricator around, although K&T has 3 drafters working for them. Any kind of questions on that? Now, we might also have these, just so you know, in all of these food processing plants, you might also have this going on. So there's quite a bit of employment in this area. A real specialized type of structural drafting is the next one I kind of listed down here, a truss designer. We probably have 5 or 6 of these right here in between Jerome and Twin and Filer, our areas. If you expand it out to Burley, we've got a few more, and certainly up into Wood River. Truss designs, folks, this is a real specialized trade, and a lot of drafters work in this area. If you ever got those skills, running that software, MyTech is a big one, you'll probably never have to look for work. This is a high demand for these types of people. I want to do a tour later this week. Maybe if we can get, Missy's not here, your class president, but maybe when she shows, you guys can have her hold a meeting and let's come up with a time that works for everybody. I prefer like Thursday, Friday, or Monday of next week. And let's go out to Quality Truss and let's go through their plant and look through it. They pretty much have a standing order that they would give us some floor time out there. They'll run us through what they do in the office, how it transmits out to the plant floor, and you can see how a truss is made, which is a roof structure. Okay. So if you would, let's try and get that to happen today, and we'll get that set up. Bridge designers, very specialized trade. You know, a lot of people have the technology in the background to actually do truss designing, or excuse me, bridge design, but you aren't going to see people do it because it's a very specialized trade again. In fact, I've got a degree where I should be able to go out and do bridge design, but if somebody comes to me and asks me to design a bridge, I'm going to tell them no, I will not do that work. Because I have not done it in industry. There's a lot of different forces that go over there. Another specialty, a dam. Now, who does dams? Usually, when you get into these real specific structures, like these giant stadiums we're building now, bridges, like the Prime Bridge, the new one we're going to put across here in the next decade or so, these are real specialized trades. And we have a couple companies around the nation that basically just all they do. And they just travel around the world doing dam design or bridge design or whatever the case might be. If you think that's good work, you know, like bridge design, ITD has a department up in Boise where there's 30 drafters in one spot, and that's all they do is the bridges around the state of Idaho. A real specific trade again. And several of our past employees have gone to work there. So you do have those options that go in. You know, maybe another example, there's one company in the world that used to build our shafts. You know, we'd do mines and we'd have to take a shaft down a half mile. Very specific deal. There's one company in the whole world that does that. And all they do is travel around and do shafts. They make a lot of money doing it because they're the only ones, but again, a very specialized trade. That's really in essence where you're going to find most of this work is done. You got your generic stuff for buildings that we've done a lot, and then you got your real specialty type of stuff, such as shafts, bridges, dams, these types of things. Now, how do you get to be one of these specialty type of people? Well, you just get your degree, you go to work there, and then they teach you these specific things, and over the course of time, you get more and more knowledge about it, and then you're able to be a more active participant in that team. Okay. I know most of you want to stay here close, like Juan, Cheryl, Missy. Tell you what, I'd be hitting these truss companies. I'd be hitting these food processing plants and things like that, and say, hey, you know, I can do this work, or just get started on it, but you can certainly get rolling in that area. Any questions or thoughts on the jobs that are available out there in this field?
Is there a certain software that, you mentioned MyTech, is there other software that some of these areas utilize a lot?
Yes. It has changed a lot in the last 10 years. It used to be that it was pretty much all AutoCAD, and you were drawing in a 2D environment, and somebody was sitting on paper doing all the hand calcs. That is really no longer the case. Now we have a lot of different software out there that is not drafting in nature, it's engineering in nature, where you just plug in numbers to it and then it runs all the calculations. And it's mostly just a speed issue, because calculations, once you get a configuration, you're going to find when we do beam design, it's just reiteration of the same calculations. And so a computer program does reiteration very well, right? Because that's what it's really kind of meant to. And so yes, you will see different types out there. Too many for me to list, Cheryl. Now keep in mind, you'll probably be working in 2 or 3. You'll use one that might be you're inputting data so that it gives you the result, and then you're taking that information to something like AutoCAD or Revit and producing the plans and elevations that you need. So the answer to your question is yes, there's a lot of other software out there. Any other questions, thoughts? Did you guys do any load calcs or anything in the welding department?
If we did, I can't remember. Might have just kind of glanced over it.
Yeah, yours was mostly this, here's my beam, now I need to weld something onto it. Okay.
Yeah.
All right, so this will be kind of new stuff for you. So keep in mind, there's a lot of jobs in this. All right, some terminology that you might want to get used to. And this is really, if anybody's had a physics class, this is kind of a repeat of that, and actually a mechanics and materials deal. So when we talk about structural drafting, remember we're looking at the physical and man-made forces placed on a structure and how we combat those forces or deal with them. We can kind of lump all of the different scenarios that go on into these kind of terms right here. Now you have 2 biggies that we always deal with almost every structural item. You have tension, which we call a tensile force, and this is where you're trying to pull something apart. So if you're taking something like this, okay, and I suspend it and I'm holding it with a bolt at the top and I hang a weight on it, that thing's under tension, right? It's trying to be pulled apart. That's tension. The next biggie, we're always dealing with tension, we're always dealing with compression. Compression is when we push together. So in essence, I take an item, I'm holding it, and I push. I push it. You just might want to make it aside. When you go into a tensile force, almost always we're immediately going steel. Okay, we get a tensile force. When we're doing compression or pushing together, we almost immediately go concrete. Okay, because those are really our 2, that's where those 2 materials excel at. Those are the two we're gonna deal with the most here. We don't have the time to come into these others. If you're interested in these and how they work, then you would have to get into an engineering program. But you should be aware of what they are. We have a thing called shear. Shear is a cutting action, and it usually happens on a beam. And actually, where it always happens, if we do get shear, it's going to be diameter divided by 4 is where it's going to happen. So in essence, what we're doing here is if we got a structural item, like let's say I got one right here, and I put a bunch of weight on it, it can cut right here. So you use the edge of the supporting device almost like a pair of scissors. That's why we call it shear. Now, notice where I show the break is, it doesn't break right on this item. It comes out just a little bit and never breaks. So we're always looking at this one. This is a beam situation for the most part. We have torque. Okay. Torque is something we have to watch out for on columns or items that are going up and down, right? Vertical, because they'll twist, okay? Kind of like this. And they'll just break themselves apart. So if I've got a big column supporting a weight, and